नमस्कार दोस्तों, welcome to Gate Wallah. I am 𝐂𝐤𝐧𝐤𝐬, Faculty of Measurements and Instrumentation. So for the electrical and instrumentation students, we are continuing the measurement series. So this is the lecture number 5. Yesterday somewhat we have faced the problem. So today I hope we won't get that type of problem. So जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा, फटाफट स्टार्ट करेंगे सेशन को। या जितने लोग लाइव में हैं एक बार कंफर्मेशन कर दीजिए बेटा। ओके, सो आज हम डिस्कस करेंगे, लास्ट क्लास में थोड़ा सा बेसिक इंट्रोडक्शन दिया है। सो जस्ट वी हैव गॉन थ्रू द इंट्रोडक्शन ऑफ द PMMC. So we have gone to the introduction of PMMC. Okay, and we have discussed about the deflection torque and we have deflection controlling torque. So आज हम डिस्कस करेंगे PMMC complete story, and if possible we will complete the moving iron, and if possible we'll go for the dynamometer also. So gate PYQs also we'll try to discuss. फटाफट करेंगे, थोड़ा सा कल डिस्टर्ब हो गया, आज नहीं होना चाहिए ऐसा. सो गेट PYQs. ओके, चलो लेट अस मूव अहेड. जितने लोग लाइव में हैं मुझे एक बार आपका स्टेटस कंफर्मेशन कर दीजिए बेटा, जल्दी से जल्दी. जितने लोग लाइव में हैं, या सो हियर हम डिस्कस करेंगे मूविंग आयरन इंस्ट्रूमेंट एंड PMMC का लेक्चर्स. सो डिफरेंट टाइप्स ऑफ इंस्ट्रूमेंट्स. सो what are the instruments I mentioned? The PMMC is only suitable for DC. These all already we have covered. Just we'll continue where we stopped. So this is the PMMC construction. If you see the PMMC construction, in PMMC we are having a permanent magnet, and in between there is a moving coil. As per the Lorentz law, whenever a current carrying conductor is placed in a transverse magnetic field, it deflects. Okay. Okay, chalo, let us see. So the permanent magnet that is made by the material alnico, once again I'm repeating, and the copper winding, the coil is made by the copper winding, and the pointer is always a lightweight, so that is made by aluminum frame. Next, the frame is also made with aluminum. The frame is made with aluminum because both are lightweight needed. And the cylinder is ferrous. Okay, and the spring is phosphorus bronze. These are the materials. Okay, there is a perfect reason permanent magnet because of the high permeability, high magnetic flux. It offers the high magnetic flux. Copper winding because best conductor, good conductivity. These are the reasons, objective questions. Aluminum because of the lightweight. Ferrous, this is because of high permeability. Okay, and phosphorus branch, this is because of what? Good conductor. And Henry, good evening, good evening. Let us hope today no streaming problem. Okay, I'm sorry, extremely sorry. The last class we faced a lot of difficulty. Since yesterday I am also not happy, so I felt very bad, and from the morning onwards I was calling to that service provider, and they have checked the tower and everything. They said everything is all right, sir. Yesterday, because of the monsoon effect, some seasonal issues in the towers, but now I think they said everything is fine. So I hope today we'll take a good session. Okay, I'm looking so smart today, Henry. Okay, thank you. Abhinav Kala, good evening, good evening. कहाँ से हो आप सब लोग? Nice to see you. Good numbers, regular numbers. Jaipur, sir, you look so handsome. Thank you, thank you, thank you very much. I'm from छत्तीसगढ़. छत्तीसगढ़ कहाँ से हो भैया? भिलाई से हो क्या? राजस्थान से. कैसे उधर मानसून स्टार्ट हो गया? हमारा साउथ इंडिया में पांडिचेरी में from yesterday monsoon started. We are feeling somewhat better comparatively last month, so we are feeling so better, and I also feeling so lightweight today. The reason is totally the hot atmosphere has been converted to cool atmosphere, so I am also feeling joyful because of the first rain. When it comes now, when the first rain touches the soil and the smell of the soil, I like very much. Okay, so last 3 months we were struggling with a lot of heat, and especially in Pondicherry and Chennai near to sea, there's a lot of humidity and there's a lot of radiation, and that too we are taking the class. This one lights, focusing light, मेरे सर के ऊपर 6 lights है, मेरे सामने एक 100 watts का और एक light है, and this board is also heat sometimes. So but now the climate is so good. Okay, in fact I want to chill this climate, but taking the class in this such a climate, it will be so energetic, and when a faculty feels energetic na, the flow of lecture will be entirely different. चलो, नाइस नाइस. अरे यार मेरे पास एसी भी है रे, लेकिन चेन्नई में एसी होने के बाद भी आपको पसीना आता है, इतना गर्मी रहता है चेन्नई में. ओके, चलो, लेट अस सी दीज आर द मेजर मटेरियल्स माय डियर. परमानेंट मैग्नेट के लिए हम ऑनली को यूज करेंगे. रीजंस भी बहुत इंपॉर्टेंट है. मैंने जो बिट्स में इधर दे रहा हूं ना, मेरा एक्सपीरियंस से दे रहा हूं. ओके, केवल गेट नहीं. मुझे पता है सम पीपल आर प्रिपेयरिंग फॉर जेन को, सम पीपल आई नो वेरी क्लियरली दैट गेट के लिए ये पर्टिकुलर कंटेंट इज ओके, बट वी हैव टू गो टू द डेप्थ. आई नो दैट, बट लेकिन मैं सब टॉपिक्स को कवर करना चाहता हूं. आने वाला एसएससी जेई एंड जेनको ट्रांसको, स्पेशली जेनको ट्रांसको में बहुत सारा बिट्स आने के चांसेस है. जहां अनटैप्ड एरियाज है, वो अनटैप्ड एरियाज भी मैं ये सेशन में ट्राई करने की जा रहा हूं. ओके ना. सो दीज आर द मेन रीजंस. फास्फोरस ब्रॉन्च non-magnetic होना है. Why? Because when the current is passing through the belt of the spring, it should be non-magnetic. At the same time, it should be good conductive. Non-magnetic होना है, and it should be conductive. Conductive means should allow the current. Conductive means should allow the current. Thank you, 𝐂𝐤𝐴. Thank you. Thank you. Nice to see you all. नहीं मैं मेजरमेंट्स का भगवान नहीं हूँ. I'm not the god, my dear. I'm just a guide for you. Don't use the big words, okay? Don't use those words. Okay? I'm nothing. Actually, I don't know anything. I just studied maybe 2 or 3 times of items more than you. That is only the reason. Okay? And one suggestion I want to give you, if you want to become perfect in any particular field, start teaching. जो भी आप परफेक्शन करना चाहते हो उसमें टीचिंग बनवा दो, ऑटोमेटिकली यू शुड बिकम ए मास्टर. ओके, जो भी फील्ड हो. सपोज इफ यू वांट टू परफेक्ट इन कुकिंग, स्टार्ट टीचिंग कुकिंग. इफ यू वांट परफेक्ट इन योगा, स्टार्ट टीचिंग योगा. यू लर्न ABCD, यू टीच AB. यू लर्न ABCDEFGH, देन यू टीच ABCD. अगर आपको A to P आता है, देन यू टीच A to N. अगर आपको A to Z आता है, देन यू टीच A to Z. ओके, आप कितना सीख रहे उतना में एटलीस्ट सम 90% यू ट्राई टू डिलीवर, एंड ऑटोमेटिकली आपको सीखने की प्रोसेस में यू आर गोइंग टू. अरे यार हिंदी भी आते हैं यार, हम तेलंगाना से हूँ, हम हैदराबाद की हिंदी, अरे हैदराबाद की धड़कन है हमारा. सो हिंदी आता है, लेकिन इतना आपका नॉर्थ इंडिया की तरफ से इतना फ्लुएंसी नहीं रहता, थोड़ा उर्दू की फ्लेवर रहता है, तेलंगाना की फ्लेवर. ओके, तो ये है हमारा पूरा मटेरियल्स एंड देयर प्रॉपर्टीज माय डियर. एंड जल्दी से जल्दी मैं जाना चाहता हूँ इसमें क्या इंपॉर्टेंट है. एक्चुअली कल हमने डिस्कस किया है डेरिवेशंस, आई एम नॉट डिस्कसिंग माय डियर, सो फटाफट करवाएंगे. सो देयर आर 3 टाइप्स ऑफ टॉर्क्स. डिफ्लेक्शन टॉर्क, let us see area of coil, area of coils cross section. So that is length into breadth. Next, deflection torque, that is Kc is the spring constant. Kc is the spring constant. अभी तो क्लियर है ना? Okay, so Kc is a spring constant. Theta is the deflection. So at steady state, the deflection torque must be equal to controlling torque. At steady state, the deflection torque must be equal to controlling torque. So I can write bina is equal to Kc and theta. So the theta is equal to Bna by Kc into I. So theta is proportional to I. Okay, my dear. And one more thing I want to tell you, the theta by I. Theta by I is nothing but a constant, that is Bna by Kc. So which is nothing but the deflection sensitivity. Deflection sensitivity. Please make a note of all these things. So it is very clear that the more is the number of turns, the more will be the deflection sensitivity. Okay, and theta is proportional to I. So if you see the graphical characteristics, of this PMMC, so this is the current and this is the deflection, and this is our graph. Exactly, the graph is perfectly uniform. So this is the uniform scale. Uniform scale. थोड़ा सा प्रॉब्लम है सर, मुझे स्टैंडर्ड डिविएशन एरर कैलकुलेट करने ही नहीं आता, प्लीज बता दीजिएगा बाद में कभी. क्या प्रॉब्लम है? कैन यू मैसेज मी दैट प्रॉब्लम? प्लीज टेक्स्ट द प्रॉब्लम और यू टेल मी द सोर्स ऑफ द प्रॉब्लम, देन आई विल गिव यू. Yeah, please make a note of all these points. फटाफट. कितना ब्यूटीफुल है स्लाइड, एवरीथिंग इज परफेक्टली गोइंग ऑन आज. कैसे सॉल्व करते हैं ये ही नहीं पता, और यूट्यूब में भी नहीं रहा यह टॉपिक, एक बार बताएंगे तो आ जाएंगे समझे। ओके, मैं एरर एनालिसिस टॉपिक में बताऊंगा। एरर एनालिसिस टॉपिक में मैं पढ़ाऊंगा। ओके जी, चलो, noted all of you? So these are the major things. Now let us see one more important representation of the PMMC. PMMC को कैसे represent करते हैं हम? So what is the way to represent the PMMC? So if you see the PMMC representation, आवाज क्लियर आ रहा है? Sound everything is clear? Yeah. PMMC का represented. So this is the representation of PMMC like a. So this is our current passing through the PMMC, and due to the number of turns it is having some resistance Rm. So there is one important concept. If you want to extend the range of the PMMC, आपको करंट का रेंज एक्सटेंड करने के लिए क्या करना है? So I want to make 0 to 5 milliamperes current to make to 50 milliamperes current. So इसके लिए हम क्या करना है? इसके लिए हम एक पैरेलल में एक शंट रेसिस्टेंस को रखना है. So this is a parallel. So this is what we call as shunt resistance in parallel. So if we keep the shunt resistance in parallel, so the properties of the shunt resistance must be, so shunt resistance must be lower resistance, so that it can offer a good passage of current. This is a ISH. So this total is our I. So the I is split into IM and ISH. Okay. So this is the range extension diagram for a ammeter. Okay. So this is what we call as a range extension diameter for ammeter. So let me draw here actually. So let me draw here ammeter range extension. If you see, so this is our diagram. So now if you see this, both are parallel. So range extension का formula very very important. ये particular concept पर आपको definitely आपको गेट में क्वेश्चन आने की चांसेस जरूर है. So गेट में आपको कंपलसरी ये कॉन्सेप्ट के ऊपर क्वेश्चन आने की चांसेस ज्यादा है, क्योंकि ये पर्टिकुलर कॉन्सेप्ट है ना, ये पर्टिकुलर कॉन्सेप्ट के ऊपर आपको बहुत सारा बार क्वेश्चंस आ चुका है गेट में. Number of times we got a question. Good evening. Good evening. Okay. So now if you see, so this particular diagram, इसमें parallel में एक shunt resistance है. Parallel में एक shunt resistance है. So if I am saying this voltage, the voltage across these two terminals are same. So the Vm must be equal to VSH. So this I can write it as Im into Rm. VSH I can take it as ISH into RSH. हमने एक शंट रेसिस्टर को प्लेस किया है. वो शंट रेसिस्टर हमेशा कैसे रखना, उसका रेसिस्टेंस कम होना चाहिए, सो दैट इसमें करंट ज्यादा आने की चांसेस है. बेसिकली ये शंट रेसिस्टर मैग्नेट वायर से डिपेंडेंट, मैग्नेट वायर मटेरियल से यूज कर सकते हैं. द रीजंस आर, वो शंट रेसिस्टर का टेम्परेचर कोएफिशिएंट ऑफ रेजिस्टेंस बहुत कम होना है, क्योंकि टेम्परेचर की वजह से उसका रेसिस्टेंस में चेंज कितना आएगा ना, वो डेल आर शुड बी वेरी वेरी लेस. Why? Because if temperature is changing and the resistance is also changing, because basically wires are made by metals. Metals को positive TCR रहता है. Temperature की वजह से resistance भी change हो गया ना, so then definitely what happened, the current also going to be properly affected. इसके लिए हमको temperature का sensitive कम होना चाहिए. इसके लिए हम material क्या use कर सकते हैं ना, manganese wire use कर सकते हैं. And the manganese wire का basic feature है उसका alpha value, that means temperature coefficient of resistance very very less. Okay, so Im in Rm is equal to ISH RSH. So इसमें हमको क्या चाहिए, अभी RSH चाहिए. So RSH I can write it as Im Rm divided by ISH. So this ISH is nothing but capital I. So capital I can take it as Im plus ISH. Yes or not? So now if I continue the derivation here, so RSH is equal to Im Rm divided by ISH. ISH I can write it as I minus Im. I minus Im. So अगर आपने you are taking Im out, so this will become I by Im minus 1. So this will become Rm by M minus 1. तो ये होगा हमारा शंट रेसिस्टेंस के फॉर्मूला. प्लीज मेक ए नोट. एक ट्रिक बोलता हूं मैं आपको, इजी टू रिमेंबर. हमारा शंट पैरेलल में रहता है, इसलिए ये m है ना, ये m नीचे आएगा पैरेलल में. शंट रेसिस्टेंस नीचे है, सो m minus 1 term will be coming in down. So this is a technique always I used to tell in the paid classes. So m is called multiplying factor I by Im. So उसको हम क्या बोलते हैं? उसको हम बोलते हैं multiplying factor. Multiplying factor I by Im. So उसको हम बोलते हैं m बोलते हैं. सुमलता, गुड इवनिंग. आजकल बहुत सारा लड़कियां भी आ रहा है मेरे क्लास को. सो हैप्पी. ओके, कुछ डाउट्स है तो बताइए भैया. Noted? Hello sir. Hello. Hello. Sir, how many times this buffering problem, sir? Live class में बहुत दिक्कत. I'm facing a lot of issues, sir. Where, sir? Perfect. So have you noted this formula? Sure. Now let us go for the range extension as a voltmeter. Yeah, now I completely reset it. चलो, So let us go for the PMMC range extension as a voltmeter. So if we go for the PMMC range extension as a voltmeter, so in a range extension of a voltmeter, what we are going to do, we are going to attach a series resistor. We are going to attach a series resistor. So this is our series resistor. So this is our meter resistance Rm. So this is our current Im. So we are going to attach a series resistor at the outside of the meter. So ये होगा हमारा RSC, ये होगा हमारा RSE, ओके, ये होगा हमारा RSE. मेक नोट ऑफ इट. अभी क्लियर हो गया? प्लीज एक बार आप सब लोग मुझे थम्स अप दिखाइए बेटा. मैंने पूरा प्रॉब्लम को स्टार्ट आउट कर दिया, तो एक बार मुझे थम्स अप दिखाइए बेटा. जितने लोग लाइव में हैं कंफर्मेशन कर दीजिए बेटा. प्लीज शो योर कंफर्मेशन. थैंक यू. So now if I am checking this one, the range extension of the voltmeter. So if we go for the complete connection, so this is our total voltage. This is our total voltage. This is our total voltage V, and this is our our VM. Okay na? So these are V and these are VM. So what I can write here, the same current is traveling. So why we have to connect a series resistor? A series resistor का purpose क्या है ना? A series resistor is for the purpose of extension of the range of the voltage. Okay. So now if I am taking the V, the capital V, I can take it as this is I into, so this is RSC plus Rm. So whereas Vm, I can take it as Im into Rm. So now if I am taking the ratio of V by Vm, if I am taking the ratio of V by Vm, okay, is all fine from your side? Dear students, please confirmation कर दीजिए बेटा. Is all okay from your side? That is a problem in the rainy season. Every time we have to check our surroundings. Is it clear? Chalo, V by Vm is equal to what? If I am taking the ratio, this will be I into RSC plus Rm, and this is Vm means I can take it as Im into Rm. So as it is series connection, so these two gets cancelled. So capital V by small Vm is equal to RSC by Rm plus Rm by Rm, that is 1. Okay. So if I am taking this V by Vm as a multiplying factor, so it will become M minus 1. So RSC series resistor will become as, so if I am taking this particular V by Vm as M minus 1 is equal to RSC by Rm. So the series resistor I can take it as RSC. So RSC is equal to Rm into M minus 1. RSC into M minus. Okay, my dear. So this is the major series resistance formula. This is a series resistance formula. All of you are there. If anybody is there in the live, please comment. Is all okay from your side now? Yes or no? Henry, Sumulata, अभिनव काला, जितने लोग लाइव में देख रहे हैं, is all okay from your side? Yeah. चलो. Any doubts? So how to remember these two formulas? I will tell you a trick. For shunt resistance, for a ammeter range extension, the shunt resistance is down. So that's why in formula m-1 has come at down. M-1 has come at down. M-1 has come at down. Okay, and here the voltmeter series resistance may, this is the series resistance value, so which is in series, so it comes series. That's why m-1 comes in the series. Rs is equal to Rm into m-1. मजा आ गया? So this is a trick that you have to remember. M-1 comes in series here. Why? Because Rs is in series, and m-1 comes in parallel here, and this is the RSH here. Chalo, now let us go for some questions, my dear. All of you get ready? If you are ready, please show me the thumbs so that I can go for the questions. अरे यार, जितने लोग लाइव में हैं मुझे एक बार थम्स अप दिखाइए बेटा, हम जल्दी से जल्दी क्वेश्चन स्टार्ट करवाएंगे. क्वेश्चंस के लिए तैयार हैं? चलो. So try to answer this question, the question number 3. Answer please. I need the reference. Very good. C बोल रहे. Very good. Why? Because the theta is proportional to I. The theta is proportional to I. So this is the current, this is the deflection, and we are going to get a uniform scale. Chalo. Try to answer. Only Vinay Kumar, answer from your side. Okay. A 100 microamperes ammeter has an internal resistance of 100 ohms. Okay, so if you see this, very simple. This is the IM. So this is our RM. And this is our ISH. This is our RSH. This is our I. This is our ISH. A 100 microamperes ammeter. So these are 100 microamperes ammeter. Has an internal resistance of 100 ohms. This is the internal resistance of 100 ohms. For extending its range to measure 500 microamperes. So this is the 500 microamperes. So what is the shunt resistance it is asking. So question को कैसे solve करना है. Okay, so anybody get the answer? I told you what is the technique to remember this formula. Ammeter के लिए shunt नीचे रहता है, shunt down में रहता है. So formula में RSH is equal to RM by M minus 1. So that M minus 1 will be at the down. M minus 1 will be at the down. That's it. RSH नीचे रहता है, इसलिए M minus 1 नीचे रहता है. वोल्टमीटर में M minus 1 सीरीज में रहता है, क्योंकि सीरीज टेस्ट सीरीज में रहता है. ऐसा रिमेंबर करने की कोशिश करो भैया. So this is M बोलो तो multiplying factor, so that I can take it as I by IM minus 1. So this is I by IM minus 1. So now what I can do here, so the RM meter resistance, that is 100 here, whole divided by capital I is equal to 500 microamperes and IM is equal to 100 microamperes. Micro gets cancel, minus 1. Don't neglect in hurry bari बच्चे क्या करते हैं ना गेट एग्जाम में, ऐसा सिंपल क्वेश्चंस मिस्टेक्स करते हैं. कैसे ना, हाँ सर फटाफट करवाएंगे, जल्दी से जल्दी करना है, बहुत सारे क्वेश्चन सॉल्व करना है. तो 100 by 5 20. बट समटाइम्स क्या होता है ना, इसमें वेरी क्लोज रह सकते हैं आप. ऑफकोर्स इसमें ऐसा नहीं है, बट समटाइम्स इफ यू सी द ऑप्शंस दे विल बी वेरी वेरी क्लोज. सो बी केयरफुल अबाउट द ऑप्शंस. सो दिस इज हाउ मच, दिस इज 100 by 5 minus 1 4. सो ये बहुत मिस्टेक्स करते बच्चे, मैंने देखा. So ये simple questions. Many persons who got 300 rank, 500 rank, actually they are eligible to get the rank less than 100. The reason behind their rank going far away is this. M minus 1 में ये 1 को neglect करते हैं, फटाफट सर 100 by 5 20 लगाए थे. लेकिन इसका आंसर क्या होगा, 5 minus 1 4 है ना, तो आंसर क्या होगा 25 ohms होगा. क्या होगा 25 ohms होगा. ऑप्शन सी होगा. क्या कितने लोग देख रहे हैं, आंसर नहीं आ रहा आपसे, टॉप में से 9 में से लेकिन आंसर तो नहीं आ रहा है. जल्दी बताओ भैया. चलो लेट अस गो फॉर द नेक्स्ट क्वेश्चन. एटलीस्ट यू डू दिस 2 and 4 क्वेश्चन आई डिड डेली. मैं एक्सपेक्ट कर रहा हूं सेशन को एनर्जेटिक होना है. सेशन लाइव में जा रहा है, आप जितने लोग लाइव में हैं, थोड़ा सा प्रॉब्लम भी सॉल्व किया मैंने, बफरिंग का प्रॉब्लम भी सॉर्ट आउट कर दिया. ओके, सो आपके लिए तो प्लीज आई हैव सॉर्टेड आउट द इश्यू. तो मैं कोशिश कर रहा हूं आप मेरा साइड से, प्लीज ऑल ऑफ यू आंसर द क्वेश्चन. वेरी सिंपल क्वेश्चन आई हैव चूजन. आंसर प्लीज, आई एम एक्सपेक्टिंग आंसर यार. प्लीज प्रोएक्टिव इन द सेशन. अरे यार आंसर्स तो नहीं बोल रहे सब लोग. व्हाट इज द पर्पस? आई हैव गिवन द फार्मूला. इतना टेक्निक मैंने बताया आपको, वो टेक्निक को रिमेंबर करना. A Galna meter with a full scale current of 10 milliamperes has a resistance of 1000 ohms. So same to same question. Why? Because this type of model question is coming very regularly. That's why I'm telling. A Galna meter with a full scale current of 10 milliamperes. Okay, so this is our IM. Has a resistance of 1000 ohms. So these are resistance of 1000 ohms. The multiplying factor, the ratio of the measured current to the Galvanomer current of a 100 ohm shunt, very clearly has given the shunt also, na? So shunt resistance also he has given the value. So shunt resistance also he has given the value. Okay, so this is shunt resistance. So this is our I. Okay, a Galna meter with a full scale current of 10 milliamperes. So this is the 10 milliamperes has a resistance. So what is asking actually? Multiplying factor. So हमने क्या करना है? RSH is equal to RM by M minus 1 लिखो. RM by M minus 1 लिखो. So here M का प्लेस में क्या लिखना है? I by IM minus 1 लिखो. That's it. लेकिन हमको क्या पूछ रहे वो? डायरेक्टली हमको M पूछ रहे. So RSH का वैल्यू दिया है डायरेक्टली. RM का वैल्यू भी दिया है. सो RM का वैल्यू कितना है? 1000 ohms. So this is RSH का वैल्यू कितना है? 100 ohms. So this is 100, this is 1000, M minus 1. So this gets cancelled. So M is equal to 10 plus 1. ऐसा मिस्टेक्स करते बच्चे, अगेन हरी बरी में क्या करते? 10 लिखते. That's what I'm telling. Those people very caution. Okay, जितने लोग हमारा रैंकर्स है ना, वो लोग क्या करते हैं ना, हरी बरी में फटाफट करके जाते हैं. सो इसमें मिस्टेक्स बहुत सारा हो सकता है. समझ में आपको? बहुत सारे मिस्टेक्स आने की चांसेस है. सो क्या होगा? M is equal 10 plus 1, that is 11 हो सकता है. इसका आंसर is 11. So the right answer is 11, option C. बहुत सारा प्रैक्टिस करो ये प्रॉब्लम को. चलो ये क्वेश्चन को आंसर कर दो बेटा फटाफट. IIT मद्रास 2003 का सवाल है. IIT Madras 2003 का सवाल है. Manganese swamp resistance is connected in series with a moving coil ammeter consisting of a milliammeter and a suitable shunt in order to minimize effect of temperature variation, obtaining large deflection torque, reduce the size of the meter, minimize effect of stray magnetic field. इसका आंसर क्या हो सकता है? I told you temperature effect is a major thing. Why? Because the temperature is alpha. Alpha of the manganese is very less. So very less, that is. So alpha is called as a positive temperature coefficient of resistance. So when the positive temperature coefficient of resistance is less, then definitely the change in resistance due to temperature is also going to be less. Okay, chalo, let us go for the next question. Yeah, answer this question. IIT Delhi 2004 का सवाल है. IIT Delhi 2004 का सवाल है. Try to answer this question. A moving coil meter has 100 turns. So number of turns is given as 100. The number of turns is given as 100. and the depth of 10 mm and 20 mm respectively. So length and breadth is equal to 10 and 20 mm. So that is 10 to the power minus 6 meter square. So which is the area of cross section. It is positioned in a uniform radial flux density of 200 millitesla. So the magnetic flux density has given us 200 millitesla, 210 power minus 3. Next, the coil carries a current of 50 milliamperes. The current is equal to 50 milliamperes, 50 into 10 power minus 3. The torque on the coil is dash. The torque on the coil is dash, that is TD. So how to answer this? Very simple. मैंने बोल दिया आपको डिफ्लेक्शन टॉर्क का फार्मूला है, डिफ्लेक्शन टॉर्क का फार्मूला है, that is BINA. Okay, so BINA डायरेक्टली बिना. Okay? मैं बार बार बोलता हूं आपको, ऐसा रिमेंबर करने की कोशिश करो, बिना. ओके, हिंदी वर्ड बिना. So B is given as 200. So this is 200 into 10 power minus 3, and the current is given as 50 into 10 power minus 3, and N is given as 100, and area of cross section is given as 10 into 20 into 10 power minus 6. तो सिंप्लीफाई करो बेटा, कितना आएगा चेक करो. So 10 power minus 6, 10 power minus 6 gets cancelled, and B is equal to 200 millitesla. I equal 15 10 power minus 3 of turns. Area is 10 into 10 sorry मैंने कट रॉन्ग कर दिया. This is 10 power minus 6 ना. So 10 power minus 6 means ऐसे कट करना इसको. One, 2, 4, 5, 6, 10 power minus 6 deduction. Okay, still हमको बहुत कम आ रहा है ना. Yeah, this is 20 to 5. अरे यार बहुत कंफ्यूज हो रहा है मुझे. आंसर कितना आ रहा है? One, 2, 3 cut. 1, 2, 3 cut. 20. 2 5s are 10. 10 into 20, 200. 200 micronewton meter आ रहा है. So this is the deflection torque. 200 micronewton meter is a deflection torque. Okay, so let us go for another question. Answer this question. A PMMC voltmeter IIT बॉम्बे 2005 का सवाल है. IIT बॉम्बे 2005 का सवाल है, जल्दी आंसर करो. A PMMC voltmeter is connected across a series combination of DC voltage source V1 is equal to 2 volts and AC voltage source V2 of T is equal to 3 sin 40 volts. The meter reads dash. IIT बॉम्बे 2005 का सवाल है. So as I already told you, series combination of DC and so there is a series combination of two voltages like this. So there's a series and the AC combination, and it is connected across. For the across, so we have connected this. So this is AC, this is our DC. So this is V1, which is 2 volts, and this is our AC voltage V2. This is 3 sin 40. And here is kept the meter. What is the meter? That is our PMMC measures only DC. So that's why the answer is 2 volts. Simple questions miss मत करना, simple questions को. Okay, so IIT बॉम्बे 2005 का सवाल है. A DC ammeter has a resistance of, so RSH is given, sorry RM. Here's a very simple direct formula questions. RM is equal to 0.1 ohm. Current range is IM is equal to 100 amperes. If the range is to be extended, that is I is equal to 500 amperes. The meter requires the following shunt resistance, that is shunt resistance RSH is equal to Rm by m minus 1. So where m is equal to I by Im minus 1. Okay, so Rm is equal to, this is 0.1, capital I is equal to 500 and Im is equal to 100 minus 1. So what we can write here, 5 minus 1 4, 0.1 0.025 ohms. So this is the, मिस मत करना, सिंपल क्वेश्चंस को मिस मत करना. चलो, so before going for the next, try to answer this IIT Madras 2019 का सवाल. A moving coil instrument having a resistance of 10 ohms gives a full scale deflection when the current is 10 milliamperes. What should be the value of the series resistance so that it can be used as a voltmeter for measuring the potential difference up to 100 volts? So very good question actually. So what is he's telling? So first of all, it is a ammeter. So this is a Im and this is the Rm. A moving coil instrument having a resistance of 10 ohms. So this is a resistance of 10 ohms. Gives a full scale deflection when the current is equal to 10 milliamperes. What should be the value of the series resistance so that it can be used as a voltmeter? So he wants to extend it as a voltmeter. So this is the voltmeter, means we have to attach a series resistor here. So this is the I. So RSC is equal to Rm into m minus 1. So what is m? M is equal to V by Vm. V by Vm. So a moving coil instrument having a resistance of 10 ohms. So this is the 10 ohms. Gives a full scale deflection when the current is 10 milliamperes. So this is 10 milliamperes. So from this we can find out this Vm is nothing but Im into Rm. So that is nothing but V is already given. So V is already given as 100 volts. Im into Rm product. So current is 10 milliamperes. So this is 10 into 10 power minus 3 into Rm. Rm is nothing but 10. Okay. So now you can solve how much you are going to get the answer. आंसर क्या प्रॉब्लम है इधर? 10 milliamperes, थोड़ा सा कंफ्यूज हो, थोड़ा सा मिस्टेक्स है. Rm is equal to, so कितना आएगा ये फैक्टर? M is coming very, M is coming 1000, right? M is coming as 1000. So this is 1000 minus 1. So 9990 ohms. So this is the series resistor. 9990. Option B is the right answer. चलो, try to answer this question. A current of -8 plus 6 root 2 sine omega t plus 30 degrees passed through 3 meters. They are center 0 PMMC. Center 0 PMMC means center में 0 है तो यहाँ पॉजिटिव आएगा, यहाँ नेगेटिव आएगा. A true RMS meter. This is a PMMC. Next, this is true RMS. Next, and a moving iron instrument. This is a moving iron instrument. So PMMC measures only DC, but here DC, but it is a center PMMC, so it measures the negative value also. So this is minus 8 amperes. True RMS measures the IRMS. What is the RMS value for this function? Square root of, so this is minus 8 whole square plus 6 root 2 by root 2 whole square. So 8 square means 64, 36. 64 plus 36, 100. Root 100 means 10. 10 amperes. Okay. So the same to same here also. This is also moving and also measures RMS, because whichever measures the AC current, so they will measure the same to same 10 amperes. So once the answers are minus 8, 10, 10. So option C. Suppose if it is not center PMMC na, if it is not center PMMC, then it will be 8. Understood? चलो नेक्स्ट क्लास में हम और अदर टॉपिक्स डिस्कस करेंगे. आज के लिए बस है. Enough for today. Thank you one and all.